Learning the structure of a graphical model. As in any approach, learning a graphical model has two parts. The first is the learning of parameters given a structure. This is relatively easier. Bontai in 1996 and in the graphical models, conditional probability tables or their parameterizations, as in equation 16.30, can be trained to maximize the likelihood or by using a Bayesian approach if suitable priors are known in chapter 40. The second, more difficult and interesting part is to learn the graph structure by Cowell et al. In 1999. This is basically a model selection problem, and just like the incremental approaches for learning the structure of a multi-layer perceptron, this is in section 11.9 that we have discussed before, we can see this as a search in the space of all possible graphs. One can, for example, consider operators that can add, remove arcs and or hidden nodes, and then do a search evaluating the improvement at each step using parameter learning at each intermediate iteration. Note, however, that to check for overfitting, one should regularize properly, corresponding to a Bayesian approach with a prior that favors simpler graphs. This is by Neapolitan in 2004. However, because the state space is large, it is most helpful if there is a human expert who can manually define causal relationship among variables and creates subgraphs of small groups of variables.